Hey guys, welcome back to another video. And in this particular video we are starting a new module. The new module is more or less about language modeling, text generation, text embedding, word embedding, and these kind of stuff, along with some other stuff which we're going to talk about later. But in this particular module we're going to start and understand about what we call the language modeling. So if you have any idea about language modeling, that would be better, but this is more or less common, people usually know about it, that is language modeling. So the idea of language modeling is pretty simple, and this is generally getting used in our daily life a lot right now. As you may have heard of something like ChatGPT, obviously you might heard of it, ChatGPT and these kind of tools or AI tools. Yeah, we usually talk about it, but the ChatGPT and these kind of AI tools on the behind works something on this particular thing called the language modeling. So what does language modeling refers to? So the language modeling refers to something like the prediction idea. Okay, so what do we mean by prediction idea? So let's say I'm assuming a sentence. Okay, the sentence is the sky is dash. Okay, this is a sentence. So language modeling basically means to find out this word or generate this particular word, what will going to come based on the probability. So our idea is to find this particular thing based on the probability, how much time a certain word might fit onto this particular place. Let's say this might be blue, this might be dark, this might be something like sunny. Okay, not sunny, blue, dark, or yeah, there might be other possibilities, but let's say I'm assuming there is two possibilities I'm currently assuming, which is blue and dark. So right now if I say something like the sky is blue and the sky is dark, how much probability these two have? To identify this particular thing, we use something called the language modeling. So now you may ask, like, how would I use it? How would I know about it? Basically, the idea is pretty simple. You need a particular big data set. Based on the particular data set, what we're going to do, we're going to find that how much time the blue is coming. Okay, so let's say how much time after the sky refers to blue, that sky is blue, how much time in the data set, and how much time the sky is dark in the dataset. So the number of times the blue is coming as forward, or the number of times the blue is coming more, the chances of this is blue is more. So the idea is this thing. Okay, we have to understand the idea of language modeling from this particular example. Now this thing comes to the picture, that how can we find the probability of blue or dark, like what are some of the methods are there. We're going to learn about it in this particular module. So the first thing we're going to learn is what we call the Ngram. What is Ngram? So Ngram basically means a sequence of words, although this doesn't explain anything, but the idea I'm telling you is you have to remember this particular thing in your head, that you might have to write in an exam or something like that, but you have to understand this thing. Ngram actually means sequence of words, but in this particular scenario, what we're going to do, we're going to find what is the probability of a word coming after a particular word. Let's say the man. Okay, then there is a white space and you have to predict the next word. So what we're going to do, we're going to find all the possibilities. The man runs, the man walks, the man dies, whatever. Let's say there are three words right here. So what is the probability of runs? What is the probability of runs after man? What is the probability of walks after man? What is the probability of dies after man? We're going to find these probabilities from a particular data set we'll be providing or will be giving to the model itself. And from this probability, we're going to find what is the best fitting answer which should going to fit right here. Now there are some of the things you might encounter in your life from when you are learning about language modeling, is that something called context. So let's say the sky is blue, but I'm saying that the sky is perfectly fine, and later I am telling you that it is blue or dark. Okay, something which contradicts. Let's say the man, I don't know what after comes this, but if I say the man something, but he's old, okay, there might be possibility that anything comes after this, but the idea is pretty simple. You have to understand the context. Okay, I'm going to give you another example. This is not a good example. I'm going to give you another example, is that the lake is dash dash. So there could be two possibilities. Let's say this is blue or green. Okay, now before this sentence somebody wrote something like this: we are in India. So now there is a high possibility that the lake could be green. Why this is a possibility? Is because in India most of the lakes are green, not a lot of lakes are blue. So the probability of getting green is much higher than the probability of getting blue. So this also depends on the context. This depends on your data set, how you are giving the data set to the model. So this is the whole idea. In the Ngram, we're going to talk about some of the like grams. We're going to talk basically n grams means one, the n equal to 1 to 3, or like 1 to 3 doesn't mean 1 to 3, 1 to any natural numbers. The idea is this: you have to have an n gram, n number of grams. What do you mean by n number of grams? I'm going to give you an example of a bigram. Bigram means 2. At the place of n we are putting 2. So at the place of n, if you put 2 gram basically means bigram. Okay, the idea of bigram means that we have to find the probability of, let's say I'm taking this example, okay, not this, I'm taking this example, only the sky, only the lake example, right man. So I have to find the probability of lake after the, okay, this is a bigram. So we are finding the probability of lake after the, we are finding the probability of is after lake, and we are finding the probability of, let's say, blue after is. Okay, okay, and I'm finding the probability of green after is. So between these two, wherever we are, or whatever the possibilities, whatever the probabilities that will going to come, we're going to put it inside the bigram or inside the place. So I already recorded this thing, but for some reason I don't know, it just got deleted, and the mic was not working into that part, so I have to pretty much delete that particular recording. So I was discussing about something called the n-grams. So we already talked about the idea of what to do in an Ngram, basically we are finding the probability of a particular word after a particular word. So that is what we are doing in the Ngrams. And to find the probability of a particular word after the particular word, we are using the idea of number of grams. What do you mean by number of gram? Number of sequence words. So we are finding the sequence words, and we are finding what word might be the next word, and we are finding the probability of it. If the probability of it is higher than one another word, we are considering that. So I'm going to give you a more detailed explanation on what the Ngrams is. So let's say the idea is that n means you have all the natural numbers. Okay, so when we are talking about a bigram or the 2 grams, okay, the 2 grams equal to means the bigram. The bigram means that you have 2 words and you are finding the probability of the next of basically the what is the like the probability of these 2 words exist like after another. Okay, like right here, lake and the. So before that, I'm going to explain you about the chain rule of probability. So this is the chain rule of probability. So yeah, you might have to remember this particular equation for this thing. So this particular thing basically means what is the probability of this sentence. Got it? What is the probability of the lake? What is the probability of lake to exist after the? This is this particular thing. What is the probability of, let's say, is to lake after lake? So you have to find this probability. This is called the bigrams. So I'm going to explain the Ngrams in a more better way. So we divide the Ngrams into like based on the natural numbers. I already talked about it. So in the case of 1, when the n is 1, that is called a unigram. The unigram basically means we are finding the probability of every word. So I'm finding the probability of the. So the probability of the will be 3/4. This is a data set. Okay. Example, based on this particular data set, I'm finding all the Ngrams. Okay. The data set contains the sky is blue, it's a dark sky, the car is waiting, the dog is barking. Okay. What is the probability of the? In the data set, there are four sentences. Okay. This S is starting, we are putting at the start of the sentence, and this particular tag we are putting at the end of the sentence to identify that the sentence is already complete. So I'm telling that how many times the exists from the entire sentence. So that there are 4 sentences, and in the 4 sentences the exists 3 times. So I'm telling the probability of the is 3/4. Then next we are finding the probability of sky. The probability of sky is 2 times between the 4 data sets. Okay, between the 4 sentences, the sky exists 2 times. So I'm telling the probability of sky is 2/4. Similarly, if you are calculating a bigram, or where the n equal to 2, we are finding the probability of one word after another. So the probability of sky after the, you have to see the data set. Okay, in the data set, how many times sky is appearing after the? So the sky is appearing after the only one time. So the probability of it will be 1/4, as 1 is appearing of the whole sentence and 4 is how many data sets are there. Similarly, how many times the coming after the starting of the sentence. The coming 3 times out of the 4 data sets. So we are putting 3 divided by 4. Okay. Let's say for the trigram, we have to find the probability of this particular thing exist. This will also be 1 by 4. As you know, it is also the sentence of the starting of the sentence is with start of the and s and then the sky. Whenever you are finding this particular thing, you have to this is the probability of this to exist inside the data set. Okay. For the most amount of time, we actually use the unigrams. Most amount of time we actually use the bigrams only. Got it? So whenever we are finding something or calculating something, there are more number of times we use bigrams than the trigrams or the whatever grams are there. Okay, 4 grams or like what should I say, quadruple grams, I don't know. But yeah, why the more grams is more accurate but more calculation heavy. So if you are doing something like in unigram, so the probability of unigram, the calculation in unigram is pretty less, but the calculation of a bigram is moderate, but the calculation of trigram is really high. So you have to think and you have to choose what is the best one to use. So most amount of time we use bigrams because this is a moderate thing you can do. Remember, if you are calculating more grams, you might get good results. Okay. So this is another example I was talking about, that how you are going to find it. This is an example. This is a data set, and what is the probability of S or the starting of the sentence, or the starting of the sentence starts with I will going to be. The starting of the sentence after that I will going to be, the chances of it is 2 by 3, as right here it is starting with I, right here it is starting with I. What is the probability that the sentence starts with Sam? The probability of the sentence starts with Sam is 1, so it will be 1 by 3. What is the probability of am coming after I? So the probability of am coming after I is 2 times out of the 3 data sets. So here I was talking about one particular thing, I'm coming to it later, but the idea is pretty simple. If you wanted to find what will be the next probability, you have to find it using a bigram or a trigram. So there is a issue, might be this one will be, this is actually incorrect, this one is correct. Okay, so what is the probability of this? If I wanted to find the what might be comes after the sky is pretty dash, what could be the word at the place of dash? You may think it could be blue, it could be dark. There's a probability of dark is higher, but you have to calculate it via like this. So you have to calculate all the, you are assuming that this word will going to exist there. Okay, and what you have to find? You have to find the probability for the dark. So this will basically be equal to something like this. Okay, probability of the sky is pretty dark divided by sky is dark. Got it? Sorry, not this. I got it wrong. The sky is pretty. Got the idea? What is the problem? Again, this is more accurate, that you might find the exact sentence there. So you can tell that, yeah, the probability of this is more higher. Because why I am calculating all these things, you have to understand this pretty important. This is important. Okay, so let's say in our data set there is a sentence called pretty dogs. Okay, I also wrote it here, pretty dogs. So if you are calculating a bigram, so you might get similar probability for pretty dogs and pretty dark. These might be the same probability. So the more gram you use, if you use, this is not a n gram, this is not a bigram you are using, it might be 4 grams. Okay, but when we use something like this, we can surely get dark more, because pretty dogs does not make sense. But if you're using bigram, so there is a probability of the sky is pretty dogs can also happen, right? This is the thing I wanted to say, convey. But what if the idea is that, what if something does not exist in our dataset? Right here you can see that inside here we get the idea that it has I am and Sam. We are calculated a whole thing, right? But what if I wanted to find a probability of was coming after I? Now here you can see was does not exist, and the probability of was coming after I is 0. But if we are getting something like 0, that is a problem, right? Because if we multiply it with 0, then the whole probability is 0. So we are not getting anything. So basically the idea is that whenever you find all the probabilities of the entire section, you have to multiply the whole thing to get the probability of the sentence what we wanted to form. So let's say I wanted to form a sentence like I am Sam and I do not like eggs, do not like green eggs, let's say. So all this vocabulary already exists in our corpus or the data set. But what if I write something like I was Sam? Okay, or I was Sam. Okay, so the was does not exist, even though there is a high probability of these sentences or these words might exist two after another, but the was is producing a 0, and because the words is producing a 0, the entire sentence will going to be 0, and if the entire sentence is 0, then there is no point of calculating the probability. So the out of vocabulary is the main problem. Now we're going to fix this problem by understanding one algorithm. So right now I already did some calculations again, but I'm going to explain it to you in a pretty easy way. I think I already calculated it in front of I recorded the whole video again. It got for some reason cut. I don't know why, but yeah. The idea is we have a corpus right here, which is I like ML and I like NLP. We have to find the occurrences. Should I remove all the things? Okay, let's explain. Okay, I'm just going to move it downwards. So also downwards. Yeah, I'm going to find the occurrences. So what is the probability? What I'm doing, I'm calculating all the unique words and I'm putting it right here in this particular column, and I'm putting also the same thing in the row. What is the next thing I'm doing? What is this thing, all the occurrences, what does it mean? It does mean that what is the probability of S coming before this particular thing. Got it? What is the probability of, at the first thing means, what is the probability of S and S are coming? What is the probability of S and I are coming? What is the probability of S and like are coming? Something like this. Got the idea? So I'm calculating this. What is the probability of S and S are coming? Is there anything like S coming after the starting of the sentence, coming after the starting of the sentence? No, right? It is 0. So that's why I'm putting 0 right here. What is the probability of I coming after the starting of the sentence? It is 2 times in the corpus. It is coming after the start of the sentence. Like is 0. Obviously it's like is not coming after the start of the sentence. ML is 0, NLP is 0, the sentence of the sentence is 0. You can pretty much calculate it on your own. I coming before S, obviously not true. I is coming after S, so this will be 0. What is the probability of I coming after I? 0. What is the probability of like coming after I? Yes, 2 times. In the entire corpus, I like exists 2 times, so the probability will be sorry, not the probability, this I'm stating it wrong. The occurrence or the bigram, you can pretty much find the bigram. The occurrences is 2. ML does not come after I, NLP also does not come after I, and end of the sentence I, there is no sentence exists which ends with I, so I'm putting it as 0. Remember, everything I'm calculating is from these 2 corpus. Okay, like coming after the start of the sentence is also 0. Like coming after, like coming before I is 0. Like coming before like is 0. Like coming before ML is 1. Like coming before NLP is 1. So I'm putting it as right here. ML coming before S is 0. ML coming before I is 0. ML coming like is 0. Going. At the end of the sentence, coming ML coming before the end of the sentence is 1. Similarly, NLP coming before the end of the sentence is 1. And end of the sentence does not come in before end of the sentence. So it is, everything is 0 right here. So this is how we find the occurrences. Got it? I might stated some of the things wrong, but you are intelligent enough to calculate it on your own. So the next thing is we're going to calculate the probability. So this is the probability I have already calculated. But yeah, I'm going to explain it to you in a pretty easy way. Basically, how you are going to calculate the probability is based on the previous word. Got it? The previous word basically means what is the probability of this particular row is coming. Row, not it is a column, right? So the columns index will going to, what is the probability of that particular thing, how many occurrences does that is coming. Okay, I'm going to explain it to you in a easy way. Let's say okay, I'm finding the probability that after the start of the sentence, how many times the I is coming. So I have to find how many times the start of the sentence is coming. So the start of the sentence is coming for 2 times. So I'm going to divide this. Okay, I did something. Okay, give me some amount of time. I'm just going to replace this with zeros as I was actually calculating something. Actually changed it. This one will be 2. This one will be, this one is 0, right? This one is 0. This one is 0 also. This one is 0 also. Got it? Okay. So I have to divide the number of times the start of the sentence is coming with this number of time the I is occurring after S. So the S is coming. The S is coming before I. 2 times. So I have to divide this by 2, and I already divided it by 2. Okay, right here I is coming before like 2 times, right? So I have to divide it by 2 again. So I already divided it by 2. Okay, right here ml, before like is coming before ml, and the like is coming for 2 times, so I have to divide it by 2. Similarly, before NLP, like is coming, so like is coming 2 times again, so I have to divide it by 2. That is how I got 0.5. This particular thing, the end of the sentence, ml is coming before end of the sentence for 1 time, so I have to divide it by 1 basically. So actually I wrote it wrong right here. I have to divide the sentence with 1, and this sentence will going to be 1 also. Got the idea? ml is coming before s, so the number of occurrences of ml is 1 in the entire corpus, so I have to divide it by 1. And the NLP is also coming before the end of the sentence is 1 time, so the probability of the end of the sentence will also be 1. But as you can see right here, the probabilities, whatever I have calculated, is pretty, I should say, there are a lot of zeros there. So if I wanted to calculate a probability which does not exist means I wanted to calculate the probability of like coming after before I. Okay, there is no sentence where like is coming before I, so that sentence will be rejected and the probability of it will be 0. So if I try to find the probability of the like all the valid probabilities which also exist, and one particular probability which does not exist, so the entire probability will be 0. That is the issue. So we fix this issue by using a method called smoothing, and I'm going to discuss about it in a second. So the idea of smoothing is that we're going to understand about the Laplace add k smoothing. Laplace add k smoothing. The idea of smoothing is nothing but like give the out of vocabulary words or whatever the words which have a probability of 0 and add k or 1 to it. Let's say if I add 1 to the whole thing, again make sure to do this, that make sure to remember that the one we are adding is for the let's say to the occurrences, not to the probability itself. We have to calculate the probability by ourselves. So this will be 3, this will be 1, and give me some time, I'm going to do it by my own. So I have calculated the whole thing, and from the idea of it, so we have to plus all the occurrences. We are doing in Laplace add 1 smoothing, so I have added 1 to all of the occurrences. After this particular thing, what we have to do, we have to calculate the probabilities. We haven't calculated the probabilities, we have calculated the occurrences. So how would you calculate the probabilities? So the probability formula will be something like there's a formula to it. Basically, how would you going to calculate it? Is that you have to find the previous occurrences and you have to plus all the vocabularies which is there. Okay, there is no, you might not get anything after I said this. The idea is pretty simple. Is that you already calculated the probabilities. Now what you have to do, you have to pretty much what you have to do, you have to pretty much divide the whole thing, divide this particular occurrence with the before probability. I'm going to explain it in an easy way. Okay, let's assume this. I wanted to find the probability of s before I. Okay, what is the probability of I after s? I wanted to find this probability. How do you find it? Before. So before, the idea was pretty simple. I would do if I wanted to find it before smoothing. Before smoothing is basically I wanted to find the occurrences of s which will going to go under this section. The occurrences of s is 2, and the occurrences of s after I is 2 also. So the probability became 1. We know about it because we calculated this thing right here. Got it? Now the probability will going to change a little bit. The probability of I for s, like s coming before I, will be something like, okay, at the bottom you have to add it with the vocabulary size. What is the vocabulary size, you may ask? The vocabulary size is this one. How many unique characters it has, and plus these two values. Okay, the occurrences is 6. Start of the sentence, end of the sentence, I like ML and NP. These are the 6 vocabularies are there. So you have to plus it with 6 and have to add the previous value, which is 3. Not 3, the occurrences. The occurrences is now 3 from here. The occurrences was 2 before. So now it is 3. So the value of it will be 3 divided by 8. So this will be 0.375. Okay, 0.375. Got it? The interesting bit is you have to find all the zeros. So the zero probability is that let's say the probability of s coming before s. To find this, what we're going to do, we're going to find the occurrences. The occurrences is 1. The probability of it is 0, right? It is 0 because it never came. Yeah, or should I say it came actually? But yeah, it is 0. Okay, it came actually because the s actually exists 2 times, so it is 2. So it will be 1 divided by 8. It is 0.125. The 0 doesn't exist right here. So wherever there is 0, it will be converted to 0.125. This is how Laplace add k smoothing controls the probability of 0. So 0 will not going to come. You can calculate this whole thing by your own. I'm not calculating it right now. You can calculate it on your own and see whatever I have done. And yeah, this is pretty much the example of Laplace add k smoothing. From the other videos, there are 2 other smoothing techniques which are there, which is written bell and good Turing. I might discuss it later. The next videos will going to be more about the word embedding and these kind of stuff. So yeah, thank you for this video. This is that much for this video. Okay, goodbye.